That was very Arabic. That was pretty cool. All right, students. So let's see. We're going to move on to the second part. And what we'll be doing now is what we call the ambiguous case of the law of signs. Okay, so this happens when you have SSA, or if you prefer, ASS. Okay, whichever. I'll be politically correct, I guess, and just say SSA. All right. So whenever you have this case where you have two sides and then an angle that's not in the middle of those two sides, turns out it's kind of weird. There's like three possibilities. That you could have no triangle is even possible. You could have one triangle, or there are two triangles possible. All right, so to show you on this, I'm going to open up this applet here, and let's see if this will show this the way I want it to. All right, so here's kind of the idea. Okay, what you have is you have a side, and you have another side, and then you have an angle. Okay, so it all kind of depends on how these things relate to each other. If you look at this right now, this side here is not big enough to go down and connect to a third side of a triangle. If I change this angle a little bit, it's still not big enough, but if I move that down, eventually we can make a triangle out of it. And actually right here, we have two possible triangles. You have this triangle ACB2 and this triangle ACB1. So that all depends on the sides of these triangles and how they relate to each other. It's possible sometimes that you can't even make a triangle out of it because this side A might be shorter than the height of that triangle. So there's all kinds of possibilities on this. It's kind of hard for me to get this thing down to where it's just one possibility, but you could have one possible triangle, two possible triangles, or no triangle at all. Okay? So the idea is, this is what we call the ambiguous case, or I like to call it the ass case. Okay, we want to see why this is. You can kind of look at what I was showing you with that applet. You might have this side A not being big enough. You might have it big enough to make one triangle, or you might have it big enough to make possibly two triangles. Okay, it all kind of depends on that. So on this next page, I'll kind of summarize what these things are. You don't necessarily have to know this information here. You just need to be able to solve the problem, and as you solve it, be able to figure out if there's a solution or not, or one or two solutions. Okay? So the key thing on this one is you have no triangles possible if this side A is smaller than the height, and that height is smaller than B. So in this case, this side is in between the height of the triangle and that side B. That would mean that you have no possible solution. Okay, you could have one solution in two different cases. If you had side A is the same as the height, and that's still less than B. So think about this making a right triangle where this side A is the same as the height of the triangle, and there's a right triangle solution. Okay, the other possibility is you could end up with this side A being bigger than B, and then it turns out that 0 is less than sine B is less than 1. Okay, so this sine of this angle here ends up being between 0 and 1. And then what happens is if you have two solutions, it turns out that this side A is less than B, and then the sine of this angle B2 is between 0 and 1. Okay, now you're not going to have to necessarily know that. The way I tend to teach this is I just say roll with it, and the math will tell you how many solutions you have. So that's what I'm going to prove to you here. Okay, so let's start with this first one. Now, what we want to do with this is we have this given triangle. So we're going to go ahead and just draw a picture. It doesn't really matter if the picture is drawn to scale or not. So I'm going to call this angle beta, and that's given as 58.3 degrees. And then we have this side B, which is a little side that's 4.47 units. Then we have a side A. Now, it doesn't matter which one side. I'm going to call this angle A, and I'm going to call this down here, this side 22.6. So what we have is we have an angle side case as we go around the triangle like that, angle side. Okay, that angle is not between the two sides. Okay, well, I'm going to go ahead and just kind of connect this into a triangle. And if you were going to start this problem, the only way you could even possibly start this would be to match up these pieces right here. Again, law of sines, you always have to have an angle and the side opposite. So I'm going to match up this ratio like this. Okay, when we put this together, I'm going to put the sine of that unknown angle alpha over its side opposite, which is 22.6. And then I'm going to match this up with the sine of 58.3 degrees. And then we'll put that over the 4.47. Okay. Now, like I said, the math will bail you out. And it'll tell you how many solutions you're going to have. If you just do law of sines and a little bit of logic, you'll be able to reason this out fine. Okay, so what I'm going to do is I'm going to multiply both sides of this triangle by 22.6. And I'll get out my calculator. So I've got sine of alpha is equal to 22.6 sine of 58.3 all over 4.47. Okay, so I'm going to go ahead and just take my calculator. I'm in degree mode. I want to make sure I'm in there. Okay, so what I'm going to do is 22.6 times the sine of 58.3, and then divide that by 4.47. Okay, like that. And let's write down what we have. So we have the sine of alpha is equal to 4.301640061. Now, I want to ask you on this, do you know what the answer to this is? In other words, think of the unit circle. Is there any place on the unit circle where the sine is bigger than 1? No, there isn't. So if I was to go through on my calculator, if I didn't recognize this, if I just do the sine of the 4.3, I'm just going to round that off. Okay, well, I'm going to get an error. So that means that this triangle has no solution. Okay, so this would be the first case of the ambiguous case where you have no solution. All right, so it's impossible to have that. So going back on the previous page, or on this diagram here, what happens is this side A is less than that height. Or in this case, it's actually this 4.47 is less than the height of the triangle. Okay, so you don't really have to know that. You just need to know that, okay, the math, when we put this together, anytime we end up with a sine of an angle greater than 1, then it's impossible. Okay, so that's case 1 of the law of sines, okay, of the ambiguous case. Right, now I'm going to look at, I think, 4 examples, just kind of give you an idea of everything that can happen on this. Again, you don't have to know the rules as much as you need to know you have a side-side angle case, and then know that you're either going to get no solution, 1 solution, or 2. That's what you have to know when you're putting this problem together. Okay, so what I'm going to do on this, I'm just going to draw a triangle. Doesn't matter if it's drawn to scale. Alpha is 30 degrees. Side A, the side opposite, is 3.9 centimeters. I'm going to go ahead and call this angle beta, and then this would be B is equal to 7.8 centimeters. So again, notice that what I have is I have a side, then an angle. Okay, so that is the dreaded S case. All right, so here's what you got to do on this problem. You have to start it this way. You match the beta up with the side opposite, and then you match up those things like that. So you start the same way I did the last problem. So we're going to say sine beta all over 7.8. And then we're going to set that equal to the sine of 30 over 3.9. Okay, now we're ready now to solve that ratio. So what I'm going to do is multiply both sides by 7.8. All right, and we'll get the calculator out and see what happens. So we have sine of beta is equal to 7.8 sine 30 degrees all over 3.9. Okay, so I'll take the calculator and see what happens. If this thing turns out to be bigger than 1, then it's the no solution case. All right, so let's clear all this mess off of there. So we got 7.8, and let's see, sine 30, and then we're going to divide that by 3.9. I think this might be 0.5. Yeah, that's what I thought. Okay, so that's the sine of beta is equal to 1. Okay, well, it's okay for the sine to be 1. Now, you could go ahead and do the inverse sine of 1. If you don't know what that is, you get this on the unit circle. So inverse sine of 1 is going to be 90 degrees. Okay, so what we have is we have beta equals 90 degrees. Okay, so we've got the first part of the problem put together. Now, I'm going to just kind of put together the results over here as we go. So we have beta is 90 degrees. And I like to just go in and sort of fill things out as I go. All right, and don't worry about whether it's drawn to scale or not. That doesn't matter. So anyway, this would be your angle gamma, and that would be C. So the second thing I'm going to do is I would have to go ahead and find angle gamma. Okay, so angle gamma, I keep writing that the wrong way. I always have a hard time writing that. It's kind of like a Y. Okay, so that is 180 degrees minus 90 degrees minus 30 degrees. So the gamma is equal to 60 degrees. Okay, so that's the second part of the problem then, is gamma is 60 degrees. Okay, now we have a third part of the problem. We actually have a right triangle on this. So the third part of the problem, I'm going to go ahead and fill that in as 60. And then I've got need to find C. So if I find side C, I need to match it up with the side the angle opposite. Then I'm going to match that up with these two parts here. Okay, so by the law of sines, what I would have, I don't want to install this. Go away, Dell. So let's see, we're going to do C over sine 60. So let's get that set up. So C over sine 60 degrees is equal to, and then we're going to do 3.9 over the sine of 30 degrees. Okay, so I'm ready to solve this. So what I'm going to do is I'm going to multiply both sides by sine of 60 to get that to cancel out. Okay, then I'll go to the calculator and then we'll approximate what C is. So we're going to do 3.9 sine 60 all over sine 30. And then we'll round that off to, I guess, 1 decimal point then. Okay. All right, and let's see. So what we'll get on this is 3.9 sine 60, and then divide by sine 30. And we'll round that off, so that is going to be about 6.8. All right, and then that'll close off the answer of the problem. So we have C is approximately 6.8. So this one would actually have only one solution. And that's because there's only one angle in this statement. What you're going to find is this statement right here is going to kind of take you in the right direction. Either it's impossible, or it might give one answer, or it might give two answers. Okay, so it's this statement that's going to be the critical one when you do this. Since there was only one place on the unit circle where the sine is 1, namely 90 degrees, that gives you one answer. Okay, so that's the one solution case then. Okay, let's move on to this next one here and see what we're getting ourselves into here. All right, so again, I'm just going to draw a triangle. So I'm going to label this time, that's A, that's 50 degrees. I've given side A, opposite that is 3 meters. And let's see, this time I'm going to call that B. And this is going to be 2. It doesn't matter which angle is the B and which one's the C. So I've got that. So that's the setup of the problem, is I have that then. Those are the 3 parts of this that I have. So the only way to start this then would be to actually find this sine, the beta. You can match that up with the opposite side, and you can match up the 50 degrees with its opposite side, and then you can form your law of sines ratio. So what we'll have is sine of b over 2 is equal to the sine of 50 degrees over 3. All right, so that's our law of sines. Now what we need to do is just solve this ratio. So sine b over 2, sine 50 over 3. All right, all I need to do is just multiply both sides by 2 to get that to cross out. So now I'm solved for sine beta, and then this will be the critical statement right here. All right, so I'm going to put this in the calculator. So I'm going to do 2 sine 50 degrees, close parenthesis, divide by 3. Okay, it's not bigger than 1, so that means that there is a solution. Now what's going to happen on this one is I think we're going to get more than one solution. So let me explain that. So I'm going to write down 0.5106962954. Then I'm going to do the inverse sine of that quantity on my calculator. Okay, and you don't have to necessarily, when you're doing your homework, write all this out, because you can do this all on the calculator anyway. So I'm going to go inverse sine. I'm going to use the ANS key, and then that'll give me an angle then. So what we get on this now is we get 30.7 degrees. However, there's another possibility. So this is what you got to understand. This is giving you a quadrant 1 reference angle. So that is right there, 30.7 degrees. We also can get a reference angle over here though. All right. So what we would do is this angle, this quadrant 2 angle, would end up being 180 minus 30.7, and that would give us another possibility. So I'll take my calculator and go 180 minus 30.7. All right, so that's going to give me an obtuse angle that might be another possibility. So we're going to write that down as 149.3 degrees. Okay, so again, this statement right here is the key to the law of sines, the ambiguous case. There's 2 possibilities on that problem, okay? All right, if you don't believe me, I'll prove it to you. Okay, so if I was to do sine 30.7, notice that I'll get, okay, that what I started with here. And then if I did the sine of 149.3, notice that I'll get just about the same thing. Okay, so that's the idea. There's 2 possibilities. So what we're going to do is we're going to go ahead and work with this possibility. Okay, I'm going to label that in my triangle as 30.7, and I'm going to kind of record things as I finish this up. So right now I've got B is equal to 30.7 degrees, so I've got that. All right, so now I'm ready to find C. So the second step in this problem, I would be ready to find C. Well, C is 180 minus the 50 that I was given in the problem, minus the 30.7 that I just found. Okay, so I'm going to go ahead and do that. And if I do 180 minus the 50 minus the 30.7, then I'm going to get C is 99.3 degrees. Okay, so that would be the second part of the problem then. So I've got that. And I'm going to write this in as I go. So that's 99.3. So that leaves us with the third thing to find would be side C. So if I find side C, then I just need to do this. Match that and that up. Then I can match these 2 up there. Okay, trying to use the parts that I was given in the problem. So what I'd do is I'd say C over sine 99.3 equals A 3 over sine 50. Okay, that should be a pretty simple ratio to solve. So I need to multiply by sine 99.3 on both sides, okay, to get that to come out. and then I'm ready to go to the calculator. So C is equal to 3 sine of 99.3 degrees all over the sine of 50 degrees. All right, and then I'll just take the calculator and I'll round that off to 1 decimal. So 3 sine 99.3, and then divide by sine of 50. All right, let's see what we got here. Okay, so that looks like that's about 3.9. Okay, so that would be the first solution of this. Right there, that is your first solution. Okay, now, what we're going to look at is see if we have a second solution. So the question we're going to ask is, do we have another solution? All right, well, this is what we got to do. All right, so we're now going to take this angle here, and we're going to work with this. Okay, so what we have in our original diagram, we were given that A was 50 degrees. Okay, so let's see. Let me kind of redraw this so it's more drawn a little bit more to scale here now. What we just figured out is it's also maybe possible to have a 149.3 degree angle for B. Well, here's the thing. If we wanted to find angle C, then we would do 180 minus 50 minus 149.3 degrees. So if we do that, I think you're going to get some answer that's nonsense. Okay, let's do that then. 180 minus 50 degrees minus 149. 0.3 is going to give me a negative angle. So negative 19.3 is not possible in a triangle, so that means we only have one solution. Okay, that's it. All right, so the only answer to the problem then would just be B is 30.7, C is 99.3, side C is 3.9 meters. So when you get these two angles, either it will work and give you a sensible third angle, or it won't. Okay, so if you kind of go back to this previous page, this is the one I just did here, is if you crunch this out, you would find this side's bigger than that side, and then the sine of that angle was between 0 and 1. So notice on here, this statement is between 0 and 1. Okay, and this side A is bigger than that side B. So that's why it turned out to be that way. Again, you don't have to know this stuff. I'm not going to require you to know that. You can look that up if you want to, but I just say do the math and let the math lead you to the answer. Okay. All right, so let's try one more of these. Let's start with, it looks like I gave you an angle B. So B is 40 degrees. The side opposite's 2, and then I'm going to call this C, and C is equal to 3. I will call this angle A, and that side A like that. So again, it's the ASS case. You have an angle, then a side, then a side. So it's ASS or SSA if you want to be politically correct about this. All right, so here's what we got to do in this problem. The way to start is to match the angle C with its side, the angle B with its side. So step 1, we need to go ahead and form this ratio. So we're going to have sine of C over 3 is equal to sine of 40 degrees all over 2. Then we're going to solve this particular problem. So sine C over 3, sine 40 over 2. Okay, I need to multiply both sides by 3 to get the sine of C isolated. Okay, so the sine of C is going to be 3 sine 40 over 2. And then I need to go to my calculator. Okay, and this is the key statement. Either it's going to be impossible, give one angle, or two angles. Okay, that'll kind of tell you how many solutions you have then. Okay, so we have 3 sine 40. And I'm going to divide that by 2. So that's going to give this. Okay, that's between 0 and 1. So that means we're going to get two possible answers when we do the inverse sine. So we have 0.964181445. C is going to be the inverse sine of that quantity, 0.964181445. So I'm going to do inverse sine on my calculator. And okay, we get 74. So what we're going to get now is C is 74.6, or you're going to do 180 minus 74.6. So C could also be this angle here, okay? Because we could be in quadrant 2. So 180 minus 74.6 will give us another possibility. So that other possibility is 105.4. Okay? All right, so let's kind of record this as we go. So solution 1, we are going to have two solutions in this case. I'll show you why in a minute. So what we have is C is 74.6. Okay, so then the second thing we need to do is we need to find angle A. So we now have that is 74.6. So let's see, angle A is going to be 180 degrees minus the 40 degrees minus the 74.6 degrees. Okay, so that'll give us that angle, and then one more step, and then we'll have solution 1. So we go 180 minus 40 minus 74.6, and that will give me 65.4 degrees. So we now have angle A 65.4 degrees. Okay. All right, so I'm going to put that in, and then there's one more step, and then that'll finish up solution 1. So I'm going to put this over here. Step 3, we're now ready to find side A. So we also have to find side A on this problem. Okay, so if I put this together, what we're going to do is we're going to match A with the opposite angle, and I'm going to match B and 40. Okay, so the ratio is going to go like this: A over sine 65.4 degrees equals B, or 2 over sine 40 degrees. Okay, so what I'm going to do is I'm going to multiply both sides by sine 65.4. Okay, like so, and then we'll get the calculator out. So we have A is equal to 2 sine 65.4 degrees all over the sine of 40 degrees. All right, so now I'm going to go ahead and do that on the calculator, and that'll give us the end of solution 1 then. So 2 sine 65.4 and divide by sine 40. And there we go. There's our answer. So that would be about 2.8. So we've got our first solution there. Okay. All right. So that is solution 1. Okay. So there is going to be a solution 2. Here's why. Okay. The idea is you had angle C could be either of these two. So what we're going to do is we're going to kind of start over again. And we started with angle B is 40 degrees. Now I'm going to call this angle C. I'll try to draw this to scale the best I can, but I don't really have to. So that's my side of my angle C of 105.4 now. Then I've got A. So in the original problem I was given B is 2, and I was given C is equal to 3. So what I have is I've got that. So we're going to kind of record this as we go for solution 2. Okay, so what we have so far is we have C is 105.4 degrees. Okay, now what we need to do is really the first key thing we need to do is we need to find angle A. So angle A is 180 minus 40 minus the 105.4 degrees. Okay, so I'm going to do that. And we're going to see if this angle is possible. And you can tell this angle is possible, so it's not going to be a negative angle like we had on the last problem. So that's going to be 34.6 degrees. Okay. All right, so we got that. So that does mean that we have a second solution. And that means we need to just close the problem up by finding that last side. So now we have angle A is 34.6, and we need to find side A to close this off. So it'll go like this. We match A up with the opposite angle and B up with its opposite angle. So we would have A over sine 34.6 degrees equals 2 over sine 40 degrees. Okay, so what I need to do is just multiply both sides by sine 34.6. Okay, get the calculator out. So A is going to be 2 sine 34.6 degrees over sine of 40. Okay, and I'll round that to 1 decimal. Just do that on the calculator. Okay, 2 sine 34.6, close parenthesis, divide by sine 40, and we would end up having 1.8. Okay, so I'm going to record that. A is equal to 1.8. This gives us solution number 2. Okay, so the key on this was that this statement right here, at the very beginning of the problem, anytime you're doing an inverse sine of something between 0 and 1, okay, if that's between the sine of the angle you were doing and 1, then you're going to get 2 angles. Now, that doesn't mean you're going to get 2 triangles. The key is once we took this angle and the 40 that we originally had, we got a sensible angle. On the previous example, we got a negative angle, so that meant that second triangle was not possible. Okay, hope I'm not confusing you too bad here. Hey, just roll with the math, and the math will tell you how many of the answers there are anyway. So again, you don't have to know all this stuff on this diagram here. It's kind of nice to know that, but you can get by without it. So let's see, I'm going to let you do 3 problems, and then that'll close off this part of the video. And then the last part of the video is going to be applications, and then I'm going to do one more with area of triangle. So go ahead and pause, work these out, see how you do. All right, so let's see how we did. First problem, let's see, I drew out a triangle. I got the angle gamma 28.8, alpha 111.2, and side A 5.8 centimeters is what you should have got. Okay, so I started this way. I drew my diagram, and I have to start with gamma, so I match up sine gamma over 3, sine 40 over 4, solve the equation. Okay, now what happens again with this is, see, this number is between 0 and 1, so you get actually 2 angles. So if you do the inverse sine of this expression, you get 28.8 on the calculator, but you could get a quadrant 2 angle. That would be 151.2. Now, does the second triangle exist? Well, you were given beta is 40. If gamma was 151.2, then alpha would be a negative angle, so no, you don't get a second triangle. All right, so we got that. So we got gamma's 28.8. Once you get gamma and beta, you subtract from 180 to get alpha is 112. And then it's the law of sines ratio. We do A over the sine of alpha equals 4 over the sine of beta. Work out the details. That gives 5.8. Okay, so pause and study over that if you need to. That would be the solution to that triangle. Again, you can check this on a calculator the way I showed you. Okay, going down to number 2. This is the easiest one when it's no solution. You should have got no solution. So again, you've got to match up gamma with 5, and you've got to match up sine of 95 with 4. So you set up the ratio like this, and then multiply both sides by 5. Therefore, the sine of gamma is 5 sine 95 over 4. Well, the thing is that this is bigger than 1. Okay, so that's impossible. If you do the inverse sine of something bigger than 1, you're going to get no solution. So that one has no solution. Okay, the next page, you should have got 2 solutions. So I'll let you kind of look over the details on this. Solution 1 was gamma is 30.9, alpha is 129.1, and side A is 9.1 centimeters. The second solution does exist. You would get gamma is 149.1, alpha gives a sensible angle at 10.9, and then A is 2.2 centimeters. So this had 2 solutions. Okay, so you can kind of go through and look at what I did on this then, and the key thing is when you set up the law of sines ratio, you ended up with sine of gamma is something between 0 and 1, which gives you 2 angles. Your calculator gives you 30.9, but 180 minus 30.9 gives you the 149.1. Does a second triangle exist? Well, let's see. You were given beta is 20. You found gamma to be 149. 180 minus 21 is minus 149.1 is a positive angle, so yes, that's possible. Okay, well, I'll let you kind of pause and study over that if you need to make some corrections on that, and then that will close off the second part of this video just with the ambiguous case. So hopefully that's not too ambiguous for you, and you can handle that ASS case whenever it shows up. Beware of the ASS.